Hello, we're back again for some more review exercises on Unit 1 over Descriptive Statistics. So in review exercise 11, we're given a table. It has headings across the top that say class, frequency, relative frequency, and cumulative relative frequency. And the data we have going down is the class in sort of an increasing order: freshman, sophomore, junior, senior, and graduate student. And our frequencies in order are 2,500, 2,000, 1,500, 1,400, and 200 respectively. So we're going to use this to complete the rest of the table. So we're given the frequencies, as I just read them to you. And we're going to, from that, compute the relative frequency, and cumulative relative frequency, and then construct a bar graph and a pie chart for this. Please do this now. Press pause. So first of all, the relative frequency, all we have to do is divide each of these numbers by the total. So first of all, we add these up. Let's see. What is this? Add the first two, that's 4,500, 6,000, 7,400, 7,600. So we just divide these. So the first one is 2,500 divided by 7,600 reduces to 2,576. That's the relative frequency. That's the exact relative frequency in a reduced fraction form. Or we can make a decimal or percentage out of that, and in this case I've made a percentage and rounded off to 2 decimal places. So that's approximately 32.89%. Exactly 2576 is the relative frequency. The next one, we take the 2,000 divided by the total of 7,600, which reduces to a fraction of 5/19 for a relative frequency, or approximately 26.32%. That was for the sophomore. For juniors, we have 1,500 of them divided by 7,600. That's 1,576 as a reduced fraction, or 19.74% rounded off. As a senior, there are, let's see, what is that? There's 1,400 of those seniors. Divide by 7,600 total students. We get 7/38 as a reduced fraction for the relative frequency of seniors, or approximately 18.42%. Graduate students, there's only 200 graduate students, but we're still dividing by 7,600, so that reduces to 1/38, or approximately 2.63%. So those are relative frequencies. They're fractions or percentages or decimal parts of the whole amount. Now, cumulative frequency is sort of like a running total. So these are in order. For cumulative frequency to make sense, there has to be some kind of an order to it. And so if we go from the bottom up, sort of least amount of time in school to highest, the freshman is the lowest one, so there are 2,500 freshmen, so there are 2,500 freshmen or lower. Those will always start out the same. The next one we want to know, the cumulative frequency of sophomores, is how many are sophomores or lower. So we're adding these 2,500 and 2,000, the number of freshmen, to the number of sophomores to get 4,500 for the cumulative frequency there. For juniors, we're adding these first three numbers together, and we get 6,000, or adding the 4,500 plus the 1,500 there. See the cumulative frequency of the sophomores plus the juniors to give us the cumulative frequency overall for juniors. Similarly, to find the cumulative frequency of seniors, that would be adding those four together, so that's the total undergraduates of 7,400. And then the cumulative frequency of graduate students would be graduate student or lower. That's everybody, so that's a total of 7,600. Now, to do the cumulative relative frequency, we divide each of the cumulative frequencies by 7,600 to turn them into fractions or percents, or we could do the same cumulative thing that we just did. Instead of doing it with frequencies, do it with relative frequencies. So, for example, the first one's still 2,576, or 32.89% roughly. The next one is 4,500 over 7,600, which is 4,576, or approximately 59.21. Or we could have done it by adding 2576 plus 5/19 would have been 4576. That would be another way to get there. Add these first three relative frequencies, or just take the 6,000 and divide by 7,600, either way, to get 15/19 for the cumulative relative frequencies of juniors. That's 78.95%. So in other words, about almost 79% of the students are juniors or lower. Similarly for seniors, take the 7,400 divided by 7,600 to get 37/38 or 97.37%. And of course, the last one on cumulative relative frequency is always 1 or 100%. Now, to make a circle chart or pie chart or circle graph, we start with the circle, find the center of that circle, and start with some kind of line. Here we just did a vertical line, and we started with freshmen. Now, to actually construct this by hand, you're going to have to figure out what that central angle is. So what we do there is the full angle in degrees is 360 degrees around the full circle. So you multiply these percentages, these relative frequencies, times the 360 to get the degrees. So that would give you a certain amount of degrees here for this one. And you make your slice of pie or your wedge or circular sector there for freshmen. And then, again, keep going around sophomores, juniors, seniors, graduate students. And so the area of the slice of pie as well as that central angle is proportional to the amount or to the relative frequency of each of these amounts. In this case, we have a title, class distribution of students, but notice that we have listed the counts and the percentages along with the category. Now, because this one has an inherent order to it, it's probably better to use a bar graph. You can always replace a circle graph with a bar graph. Times when you'd want to use a circle graph is when you had a small number of wedges, small number of categories. There's a fairly clear difference among the different categories just by looking, and you want to emphasize parts of a whole. But typically you want to use it only when there's not an inherent order. If there's an inherent order, it's better to use a bar graph like we have here. So we start with freshmen on the left and then with graduate students on the right. So we have bars for freshman, sophomore, junior, senior, graduate student. You can see that's listed as class at the bottom. Vertical scale is frequency. Notice it starts at 0. These are two-dimensional bars, which are just rectangles. They all start down here at the bottom at 0 together, and they go up as tall as they're going to go. So this is 2,500 here and so forth. So this is a frequency. This one is a frequency bar graph, but I could have used percentages or fractions of 1 for my vertical scale and made it a relative frequency bar graph. The picture would look exactly the same, except the scale, instead of being frequency, would be relative frequency. In fact, sometimes you'll even see it done with frequency on this side and relative frequency on this side. All right, the next one I have a data set. What I'd like you to do is construct a stem and leaf plot of the following ages of students in a particular statistics class, and then construct a relative frequency histogram with the same grouping as the lines of the stem and leaf plot. Now, in this case, it looks like the students are in their teens, 20s, and 30s, and maybe 40s. So let's just try one line per stem. Your choices are basically 1 line per stem, 2 lines per stem, or 5 lines per stem. Okay, here's the data. I'll read the data to you, and then I'll pause it, or you pause it, and then figure this out, and then come back and check. The data set is 18, 18, 17, 20, 22, 21, 25, 23, 46, 23, 24, 19, 18, 19, 20, 27, 30, 37, 32, 19, and 19. Press pause now. So here we go. The way you do this is you write your stems down, 1, 2, 3, 4. I just said do it in 1 per stem, and I actually turned out and did it in 2 lines per stem. So why did I switch it? Well, with 1 line per stem, you're only going to have 1, 2, 3, 4 lines. That would only be 4 groups or 4 bars. And by doing it 2, that gives you a few more. This is probably a little bit better grouping here. 3, 4, 5, 6, 7 groupings here. One of them was blank. But 7, 6, 7, 8 groupings would be better than just 3 or 4. So actually 2 lines per stem was actually a little bit better here. Okay, and so when we put these on here, we just start one. You put the 8 here next to the 1, then an 8 next to the 1 for 8, the 2 18ths, then a 7, then a 0 next to the 2, and a 2 next to that, the 1 next to that, and so forth. Just going through these, and then you pre-order them in increasing order within each line. So when it's all said and done, the stem and leaf plot here, the stems are the 1, 2, 3, 4. The leaves are the others, which are the, I'm sorry, say that again. The stems are the 1, 2, 3, 4, which are the tens digit. The leaves are the units digit or ones digit here. So this first line represents 17, 18, 18, 18, 19, 19, 19, 19. Second line is 20, 20, 21, 22, 23, 23, 24. Then we have the higher 20s here. So this second line is 20 to 24. The third line is 25 to 29, and so forth. So we have a 25 and a 27. The lower 30s here from 30 to 35 is 30 to 34 is 30 and 32. From 35 to 39 is 37. We didn't have any low 40s, but we had 46 in the upper 40s. And so that's a probably better grouping there. So this first group went from 15 to 19. If you'll count them, there are 8 of those. So that made us a bar going up that tall. So this is a grouped frequency histogram. For the 20s, from 20 to 24, if we count these, there are 7 of those. That goes up to 7 for that height of that bar. From 25 to 29, there are 2 of those, and so forth. And you can see those. Notice that we needed to leave the space here for 40 to 44. So that's a grouped histogram and a stem and leaf plot. The stem and leaf plot gives us a nice little way to put things in order. It organizes our data, and we're grouping them together. Next, compare and contrast the 2 modified box plots and discuss the differences in test scores of the 2 sections of a particular exam, 2 sections of statistics classes on a particular exam. The top plot is for section 1, the bottom plot is for section 2. Comment on relative center, spread, and outliers. Press pause now. Okay, so this is review exercise 13. We're looking at these 2 modified box and whiskers plots, and we want to compare and contrast them. So we see that overall section 2 performed a little better on the exam. Well, how do we know? Well, first of all, its median was higher. This is a median of, looks like 72 versus a median of 69 for the first one. Not only that, you could say that the top 75% on this exam, on this section, was 69 and above, where only half of the students scored 69 and above on the other class. Now, it is true that section 2 has the lowest scoring student at 50, but that was an outlier. Except for that one student, everyone scored 60 and above. And it is also true that the highest scoring student is in section 1, up here at 92. So we have that. So but it looks like the center and overall section 2 did a little better than the other one. Section 2 is the only one with an outlier. Okay, so that was an unusual compared to the rest of the students in that class. And if we ignore the outlier, we see that the spread of each fourth is larger in section 1. So, this fourth is bigger than this fourth here, not counting the outlier. The top fourth is more spread out than the top fourth here. This third, the next to the top third is spread out more than that. This is spread out more. The interquartile range is bigger up here in 1 than that. So the interquartile range here, I believe this distance from here to here is 13 versus only 10 here. So with those observations, we see that section 1 was more variable and scored a little bit lower. Section 2 did have an outlier, but other than that was more consistent and scored higher than section 1. Okay, so let's leave it at that. Let me get back to where I want to be here. Okay, review exercise 14. On a standardized exam, John scored 35 on the mathematics portion and 41 on the language portion. The distribution of mathematics scores had a mean of 31 and a standard deviation of 2, and the distribution of language scores had a mean of 38 and standard deviation of 4. Relative to the other students, how did John score? Did he do better on the math or the language portion? Press pause now. Well, to do this and make this comparison, since we're using different scales on these things, and to do it in comparison to other students, we need to look at z-scores, which is a measure of relative standing. So what we're going to do is compute the z-score for there. So let's do z-score for math. It's his score on math minus the mean on math divided by the standard deviation of math. So let's see, his score was 35 with the mean was 31. So he scored 4 points above the mean, but the standard deviation was 2, so divide by 2, and that gives us a 2 for the z-score. So he scored 2 standard deviations above the mean for math. So he's comfortably above average. That's pretty good. Okay, how about on language? Well, take his score of 41 minus the mean score of language, which is 38. Do that subtraction first. Then divide by the standard deviation of the language, which is 4, and we get a z-score of 0.75. Still scored above average, but not a whole lot. Only 0.75 there. So which one was the best? Well, since the z-score of 2 on the math is bigger than the z-score of 0.75 for language, he scored better on the math relative to the other students. What we don't know is if these are using the same scale. What we don't know is what percentage of the questions he got right. This doesn't tell us any of those, but it does give us a way of comparing these two portions together relative to the other students taking the test. So compute z-scores and compare them for this. All right, here we have a data set. We want to compute the following descriptive statistics: the minimum, Q1, median, Q3, and the maximum. That's the quartiles. Some other measures of center, as well as the median, compute the mean, mode, mid-range, and mid-quartile. Sample size. Measures of variability, the range, interquartile range, variance, standard deviation. And finally, compute a z-score for 20. Here's your data set: 25, 26, 14, 18, 27, 29, 29, 34, 29, 18, 17, 22, 23, 22, 27, 33, 38, 40, 42, and 50. Press pause now. Now, while you could do actually all of this except maybe for the square root for standard deviation without a calculator, it's my intention that you would do this with a calculator. So here's how you would do this, let's say on a TI-84. Press Stat and Edit. So let's go to Stat, Edit, clear list 1, or put it in list 2 if you'd rather, and type in your data, 25, 26, etc. Okay? When you get all that done, you have this. Then go to Calc, okay, so actually before you hit Calc, hit Quit, then go to Stat, now go to Calculate, number 1, one variable statistics, list is in list 1, frequencies are just 1. Actually, you can just leave that out, leave it blank. And then calculate. If you have an older calculator, you don't get that little wizard come up, or like a T83, but it may say one variable stats, and you just push L1, which is second L1, if that's where it is, and then enter. Notice it tells you the mean, 28.15. Hopefully this is going to agree with what I've done here if I typed everything in right. Tells you a couple other things we didn't ask for. This is a sample, so we use a sample standard deviation 9.22. Had this, we were sure this is a population, you'd use the sigma instead for the standard deviation. Okay, and if it doesn't say, then you're going to assume it's a sample. So that was the standard deviation, 9.224, rounding off to 3 decimal places. N is 20, that's the sample size, and that arrow says we got more, which is our 5 number summary, our quartiles. 14 for the minimum, Q1 is 22, median is 27, Q3 is 33.5, and 50 for the maximum. I believe that told us almost everything here. The interquartile range is Q3 minus Q1, so you can either type it in, 33.5 minus 22, or do it in your head. Or you can get it from here, variables, number 5, statistics. And let me see, I think it's over here. Yeah, under points. You can go down here and say, or up, do Q3 minus variables, 5 statistics, left arrow to points, up arrow to Q1. So that's the interquartile range. The variance is the standard deviation squared. So don't use the rounded off version. I'm going to use the version in here. Statistics, that's S sub x, that's 3. And we want to square that. That's the variance. And then round that off. 85.082. Now what about a z-score? A z-score for 20. So you take parentheses 20 minus the mean, which I can get from here, again from statistics, and it's x bar, which is number 2, divided by the standard deviation, which again I can get from here, variables, 5 statistics, and it's number 3. And that gives us our z-score, round off to 3 decimal places, is negative 0.884. Or I could just type the numbers in instead of doing this way, but I want to make sure I type in lots of digits and round off at the end. Don't use the rounded off version to continue on. Similarly, we could look at the data here. Okay, and I could go to my spreadsheet, which is, let's see, control here will tab me back. And I could go up here. And then maybe call this data 2. And go down here and type some numbers in. Let's see, 25, 26. You go ahead and type these in. Press pause if you need to. I'll press pause and put them in. Okay, I've got all the data typed in. Now I go to, I'm just going to go over here. We'll go to Menu, Statistics, Stat Calculations. No, that's went too fast. Menu, number 4, number 1, Stat Calculations, and one variable statistics, which is number 1. Number of lists, just 1. That's good. Okay. The list is data 2, frequency 1, and the rest of this we don't have to put. The results will be shown in column D, which is fine. So I can click OK. And if I go up arrow enough, I will find everything I want here. So there's X bar and so forth. This is basically all the same stuff that the TI-84 told us as well. Alright, I believe that'll finish us up with this video. Come back. I got another video with 5 more exercises on the next one.